Hi guys, I'm David from Danfoss Climate Solutions and I want to welcome you to Mostra Convegno 2024. First of all, please let us know where you're joining from and what is your background. We are really glad to see you here. As you can see, we have the theme here, Shift Your Perspective, and this is exactly what we want you to do. We want to change your perspective on decarbonization and energy efficiency. And how are we doing that? Well, basically, we are showcasing our solutions from heat source to distribution. If we focus on heat source, you can see here our solutions for light commercial heat pumps, and also industrial heat pumps. And if we focus on the distribution side, you can find here all our solutions for multifamily buildings, commercial and industrial buildings, and also district energy infrastructures. So do you want to know more about that? Then follow me and let me present you what Danfoss brings to the show. Hi again guys, as you can see we are here under the light commercial heat pumps wall with Mathieu. Mathieu, you are one of our heat pump experts at Danfoss. Can you please introduce a little bit yourself, your background at Danfoss?
Hey guys, greetings from Danfoss at Mostra Convegno. My name is Mathieu Stoll, I'm the heat pump expert at Danfoss. This year our focus is on decarbonization solution for the heating sector, mainly hydronic heat pump but also secondary side components. So here we are standing in the multifamily and light commercial heat pump area, meaning we are showcasing our propane components for heat pump systems from 20 to maximum 200 kilowatts.
Okay, I heard propane. What are the reasons for this refrigerant to be in focus today?
So the F-gas revision has just been published into the official journal, and the updates are a steeper HFC phase down and some specific bans per application. So in our case here, we are talking about a ban on refrigerant with GWP above 150 by January 2027 for systems up to 50 kilowatts, and by January 2030 for larger systems. Propane is a great refrigerant. It offers a very broad operating map. And so by this we mean high water temperature but also low ambient operation. And on top of that, it is very efficient. This is why this is really the refrigerant of choice for most heat pump application, mainly air-to-water heat pumps, where it can be applied up to 5 kilograms per circuit, but also water-to-water system with some additional requirements. But it is a bit more complex with air-to-air systems, multi-splits, rooftop, VRFs, where charge is much more limited due to the high flammability.
Super, thanks a lot. I can see that there are many solutions, products on display here. Can you please let us know a little bit more about what we can see here in the wall?
Certainly. So let's start with the products on the podium. So here we have our new variable speed scroll range of propane compressor. It is actually part of a full range covering from 20 to 75 kilowatts in 4 different models. It offers a very broad modulation range, which will guarantee best-in-class system seasonal efficiency. The model we are showcasing here is the largest of the range, the VZH 175. It has been specifically sized to match the limitation of 5 kilogram charge per circuit. This means that it will enable our customer to reach the maximum capacity per circuit with 5 kilogram charge. In other words, 75 kilowatts in one circuit and up to 150 kilowatts in 2 circuits. Next to the compressor, on this side, we have our H118 microplate heat exchanger featuring dimple technology, which enables highest heat transfer and lowest refrigerant charge. Together with 2 other models, the H62 and the C129 dual version, we can cover the full light commercial range. Interestingly, and to be noted, that these three models are going to be re-released very soon with a full-on propane optimization, meaning a new dimple geometry to really optimize heat transfer and an optimized press depth to really reduce refrigerant charge to the minimum. Additionally, on the wall here, I'd like to spend a minute on our brand new AllSmart controller. It features latest processing power, connectivity, and security, and it comes with Danfoss full library of heat pump controls. Next, we have our ETS8M, latest generation electronic expansion valve dedicated to that capacity segment. It is a biflow valve. It comes together with its superheat controller, EKE100, also our latest generation. Finally, here we have our hermetic, D-flow, and very compact filter dryers, the ideal filter dryer for propane. And I would like to close this with two sensors here. A very new DST G290 leak detection sensor. It's going to be very useful with propane. And a new pressure sensor, the DST P070. With all of those components in your heat pump, you are guaranteed a best-in-class system. And because the decarbonization of heating doesn't stop at the efficiency of the heat pump, Danfoss is also offering a full range of hydronic components for the secondary side. This is really key to ensure optimal performance and enable the heat pump to perform at its maximum efficiency.
Great. You have been talking about the fact that good hydronic distribution is key to unleash the full potential of heat pumps in the field. But how is Danfoss addressing this topic?
So the key here is proper balancing, and this will ensure the optimal water regime for the heat pump. So Danfoss is offering best-in-class valves in this category, dynamic balancing valve, but also pressure-independent control valve that will be much needed to properly balance architectures in multifamily and light commercial, where we have several dwellings to feed and several water columns to balance. But I'll stop here. And I will let my colleague reveal all of this to you in another video.
Thanks for this amazing explanation. I'm sure that we are all now convinced that Danfoss has the right components offering to support the industry and markets in this transition from fossil fuel to green heating. But do you have anything else to add, any final word?
So, not only Danfoss has its unique portfolio spanning from the source side, so the heat pump, to the secondary side, down to the emitters, be them underfloor heating, fan coils, or radiators. But Danfoss has this unique ability to also go beyond the simple component supply. Danfoss offers a full system design services, starting from system simulation to component selection to prototype assembly, and finally testing and qualification. Based on this, Danfoss is really truly the ideal OEM partner when it comes to heat pumps.
We have been speaking with Mathieu about the light commercial heat pump solutions that we are presenting here at Mostra. We realized that a good hydraulic distribution is also important to unleash the full potential of heat pumps. Now we are moving towards the distribution side of things with the multifamily wall with Alessandro Pasuelo. Follow me. Welcome back, guys. As you can see, we are here in the multifamily buildings wall. I'm here with Alessandro. Alessandro, thank you for taking the time to be with us. Alessandro, you are the business development manager for residential buildings, right?
Exactly.
Okay, can you tell us a little bit more about yourself, your background at Danfoss and so on?
Yes, I have been working in Danfoss for almost 3 years now, and I have always been working in the residential vertical. taking care of the full portfolio in Europe as main market.
Great. I have a couple of questions for you. The first one is if you can present the secondary site installations within the multifamily housing.
Yes.
We are exhibiting here at Mostra.
Absolutely. So in this area, multifamily buildings, the key words are energy efficiency and smart. So the scope of this panel is actually to explain our solution, Danfoss solution for the secondary side, which is what comes after the generator, which is typically the heat pump or can be district heating, whatever. So scope is residential here, and these solutions are mainly for multifamily houses, apartment buildings, but also they are relevant for single family houses. If we start looking at products from the left here, we have one possible way to carry out balancing in apartment buildings. This is what we call ASP, balancing valve. It's a dynamic balancing valve that keeps a stable differential pressure on 2 points of the distribution line. Why should you do that? Because in multifamily houses, it's important that you are able to operate efficiently under partial load conditions, which means that every apartment at every moment in time should be able to operate independently from what is happening outside. So one way to do that, both in new projects and renovations, is to use a dynamic balancing valve like a differential pressure control valve on the risers. The same thing can be done on each radiator. So one example here is this valve body on this radiator. It is a dynamic type of radiator valve. It includes the same functionality of these bigger valves inside this small body. So this dynamic valve will operate so that the flow rate that every radiator will get is only dependent on the position of the thermostat and the presetting of the valve if you have done presetting, which means at the end that every radiator will operate independently from what is happening outside. And this is extremely relevant to compensate for the heat load you have in every room. We are here showing radiator thermostats, so traditional radiator thermostats, and Danfoss has recently released a portfolio of 5 new different sensors. And all these 5 sensors, they have best-in-class control accuracy. Control accuracy is a parameter which is typically used for defining the effectiveness of such products in controlling room temperature. All the 5 products have 0.2 CA value, which is the best you can get. But what it is important to notice also is that Danfoss is using on Avio and Aero radiator sensors gas bend load technology. Gas technology is a Danfoss technology that allows for a better reaction time when temperature is fluctuating, and then you get a better, more stable, would say, temperature in every apartment, and consequently better energy savings. Then if we move to this part, here we are talking about flat stations. Flat stations can also be called ionic interface units, and they are the interface between a communal central heating system and each flat in apartment buildings. Flat stations, they make heating and they produce domestic hot water, instantaneous domestic hot water, and they are fitted for energy metering, so you always find a space where you put an energy meter inside. The fact that they are a modular solution and the fact that they are intrinsically safe against Legionella, thanks to the heat exchanger that is making instantaneous domestic hot water, are making this product a very common solution in many markets in Europe. What is new today in this new product that we call EvoSat 4.0 Pro is that we have introduced an electronic controller in what it is normally a mechanical station. This electronic controller allows you, amongst other things, to do remote monitoring, predictive maintenance, and you can access the data of the heat meter when you have it remotely, either in our platform, so we provide a Danfoss platform called Danfoss Lean, or you can connect to this controller using a standard Modbus protocol via DMS. Then, connected to this flat station, we have here an underfloor heating distribution. what's relevant to point out is that in this system, we have introduced this Icon 2 controller. Icon 2 is a smart way of controlling underfloor heating. It's a device that can connect to either wired sensors or wireless sensors, like in this case here. And then it is suitable for both new projects, but also renovations. It is important to notice that this controller includes some very interesting features. One is auto balancing. So it understands automatically how heavy, how inertial, how much heat load each room is demanding, and automatically it adapts the flow rate, it splits the flow rates across all the output. On top of that, since we are in the heat pump context, it is worth noticing that there is a heat pump optimization feature. So there is an algorithm that is trying to spread the heat load over a wider amount of time in order to operate more efficiently with the heat pump, reducing the number of on-off cycles. And just to finish on the products, I have to say that these products, so smart products, they are supported by software tools. So we provide applications for installers and applications for users to remote connect their heating system and efficiently manage their houses.
Great. Amazing explanation, Alessandro.
Thank you.
I have another question because there is a lot of myths between radiators, heat pumps, and so on. But the question is, can heat pumps be used with radiators?
Yes. Yeah, actually there is the belief that a radiator to work, it needs all the time a very high supply temperature. And while this might be the case in some limited situations, let's consider a few facts. One is that normally radiators are oversized. They are oversized because they were at the beginning when they were first installed, and they might be even more oversized if during the last years some kind of energy renovation has been done, like changing windows or putting some insulation. What also a fact is that most of the installations we see, they are not balanced, which means that radiators are sometimes not working with the right flow rate. And then you need to compensate with a higher supply temperature to have the right output. The last thing, which is the most important, is that radiators are designed to compensate for the maximum heat load every flat has to face in the most extreme weather conditions. But how many days during the years can you expect the most extreme weather conditions? It's very few. So in reality, in the vast majority of the time, radiators will work at partial heat load. And then at partial heat load, lower temperature is totally fine. It is also true that heat pumps themselves are not sized to cover the maximum power load the building will need. They are sized a bit less, and then in the few days where you need a very high output, then some integration will be needed. But the message is, most of the time, your radiator will work efficiently with a lower supply temperature and therefore with heat pumps.
Great. And also, why is it important to have a correct balancing on the heating system?
Yeah, absolutely. So this connects to the previous question somehow. But okay, balancing is important, I would say, for two reasons. One is comfort. Comfort because it is important that every single tenant, every single apartment is somehow able to decide the set point temperature that is a comfort temperature in an independent way to others. So I should not get overheating and I should not wait too long to get my comfort temperature. Comfort is also not having noise on the heating system, because it's very common, especially in large multifamily buildings, that you need to provide a very high differential pressure for water to go around, and high differential pressure means, without balancing, that you can get some noise on the radiator valves. So if you do balancing, you are safe. But balancing is also important for energy efficiency, as we said. If every emitter, every radiator, every underfloor heating circuit is getting the right amount of water, this means you don't need to compensate, for instance, by increasing the temperature. And this is commonly done. So commonly in systems without balancing, what it is done to compensate for not enough heating is either to increase the speed of the pumps, so pushing more water, or to increase the supply temperature. And this is not good because if you increase the supply temperature, you increase distribution losses. And if you work with a heat pump, then you are decreasing the COP you can work with. If you do balancing, your system will work in the most optimal way.
Great. I think this is also in relation of my next question, which means how can multifamily buildings reduce carbon emissions?
I mean, everybody, when thinking about CO2 emissions, is thinking about the generation side. And let also us remember that if we take into consideration HVAC systems and lighting in buildings, they account for more or less 30% of global carbon emissions. So we can do a lot by making efficiency in buildings. And decarbonization can come from either the generation part. So of course, if you use low carbon or zero carbon energy carriers like electricity produced with renewables, this is fine. If you use waste heat in district heating, that's great. But what is less obvious is that you can also decarbonize by making a better use of energy. So, as we said, if every system was balanced, we would avoid a lot of energy losses in distribution and in overheating places that don't need that amount of heat. But very relevant is having, in the residential world, room by room, temperature control and time scheduling, which means that every user could set the comfort temperature in every room in the right moment in time. The comfort you would get would be optimal, but there would be no need to keep rooms warm when they are not in use, for instance. So the message is, by doing balancing, room control and time scheduling, we would achieve good or even best level of comfort without wasting energy. And that's a way of decarbonizing.
Super. Thanks a lot. That was the last question. Thanks, Alessandro. It was really, really nice to hear you talking about all these solutions.
It was a pleasure.
So we have been seeing the relationship between heat pumps and radiators in heating systems. Also, why a correct hydronic balancing is important in order to have a more energy efficient installation that reduces carbon emissions. Now, let's move to the commercial heat pump wall with our colleague Mathieu Canal. Follow me. Hi guys, welcome back. We are here under the commercial heat pump wall with our colleague Mathieu. Mathieu, you are the Heat Pump Solution Director. Can you tell us a little bit more about your background at Danfoss?
So I've been working for Danfoss since 2016, coming from the compressor division, and since more than 2 years from now, I've been appointed Heat Pump Solution Director, so I'm taking care about the strategy related to all types of heat pump, from the residential up to the industrial one.
Great. I have a couple of questions for you. So the first one, it's what type of heat pump technology is the best for commercial application?
So first of all, in order to set up a bit the scene, when we are talking here on this show about commercial heat pump application, we are talking about heat pumps that are above 200 kilowatt heating capacities. Those types of heat pumps, they're going to address most preferably commercial buildings such as hotel, offices, hospital, etc., etc. So when we are targeting this type of buildings, there are several types of heat pump that may be used, right? Primarily targeting different needs. So there is the space heating needs, and there is also the domestic hot water needs. So in order to start the journey, I would say that the first one that we know is the air-to-water heat pump, targeting the need of space heating. In order to do so, we are not today as Danfoss, we are not releasing any new products for this type of application, because this application had been, let's say, targeted a few years back with the launch for the scroll compressors of the platform of DSH and DSF that is able to cover the need of space heating, a dedicated range of line component and optimized heat exchanger for refrigerants such as 454B and R4. Also in air-to-water heat pump application, we can also target domestic hot water production, and right now this is not shown here physically, but again for air-to-water heat pump from 40 to 600 kilowatts, we are in the process to release a new scroll compressor called PSH that works with vapor injection in order to enhance the energy efficiency of the system, but also to extend the operating envelope to operate at low ambient temperature. So this is not shown here, but this is something that you can find digitally. And on top of this, when we are talking about domestic hot water production, especially in buildings where the hot water production will be predominant, such as, for example, hotel or offices, you may find also a solution with CO2. So CO2 heat pump can get a momentum in this area, and this is the type of heat pump that you may find in another wall that will be presented later on by Ivan. And last application will be the water-to-water heat pump, and this is what we're going to have in focus right now with new products that we are addressing.
This ties a little bit with the next question, because then when I want to ask you a little bit about what are we introducing in our portfolio, targeting specifically commercial heat pumps.
So right now on this wall, we are really focusing on primarily on the water-to-water application with the release of the new version of TurboCore, the active cooling version. So this is compressors that will be able to operate at high evaporating temperature, and also to operate at high condensing temperature. So what does it mean? It means that with this oil-free technology, we will be able to make domestic hot water and also space comfort. The world is not only about heat pumps, so we also need to mention that thanks to the fact that we are able to operate at higher evaporating temperature, this type of compressor will be a perfect match for data center application, because there is a need to provide higher, warmer, I would say, temperature to improve the efficiency of the data center operation. So that's one thing. So this is the active cooling version. So the active cooling version really active cooling word refers to the fact that we are cooling the electronics. So even if it's an active cooling, it really works well in a water-to-water heat pump application. Close to it, you will find a new component called OFC, the oil-free check valve. So this is a component that has been primarily designed for TurboCore application. That provides quite good, so it's a check valve that provides good benefit, lower pressure drops that can then improve the efficiency of the system. It's more compact, and it's also benefit in terms of noise of the application. So that's it on the compressor part. Here today, it's a world premiere where we are launching our new universal programmable controller. So this is AllSmart. So this is a modular programmable controller. So it's an open programmable controller where you can use different programming language in order to code your software. It also provides the latest IT security benefits. On top of this, AllSmart does not come only with an hardware, but we are also working with application framework software. So when you are buying, for example, a TurboCore and you want to come with a solution that is already working, we have already some software libraries that works with TurboCore. And of course, for what concerns all the line components that you see on this booth on commercial heat pump, they are all working with, they are all suited for oil-free application. And last but not least, in terms of heat exchanger, we released, I think 1 or 2 years ago, I don't remember, our biggest dual plate heat exchanger called the C262 that is able to operate from 200 up to 800 kilowatt heating capacity with kind of a unique plate design. So this is, I would say, all what's new in the commercial heat pump world related to water-to-water application.
Super, really nice explanation. This brings me to my last question. Where Danfoss is currently investing in long-term development?
So So thanks. So in long-term development, I think you have already the presentation done by Mathieu, where there is a huge focus on propane. So that was much more on a light commercial application up to 200 kilowatts. The next step for us will be to qualify first our scroll portfolio with propane. So in order to target capacity that will go up to 200 to 600, 700 kilowatts with propane. So that will be. This is something that we have under focus and on the radar. On top of this, what we are also working on is to develop new solutions to optimize the integration of a heat pump within a building. So that you find the solution on the other side about the importance of the hydronic portfolio and the water distribution within the building in order to have the heat pump operate at the best condition as possible in order to enhance as much as possible the efficiency. So those are, in terms of products, our go-to market. And the last thing that's where we want to invest in the future, we want to be the partner for decarbonization, and also as a service. We are a component provider, but we can also be. We want also to be seen as a much more a solution provider, where we are able to provide support to our customers in terms of system simulation, in terms of laboratory, and in terms of application expertise. So this is where we want to position ourselves in the future.
Great. Thanks a lot, Mathieu. I appreciate the fact that you spent some time with us. And guys, stay tuned because the show continues. So we have been chatting with Mathieu in front of the commercial heat pumps wall, speaking about source generation in commercial heat pumps. Now let's move to the distribution side of things with our colleague Andrei. Welcome back, guys. As you can see, we are here under the commercial buildings wall. We are here with Andrei Kastelic. Andrei, you are the Senior Product Manager for PICV's portfolio, that's Pressure Independent Control Valves. Can you please let us know a little bit more about yourself?
Good morning also from my side. We are here at Mostra Convegno exhibition at Milano, and today I will be presenting our part, hydronic balancing and control. So at Mostra Convegno, we're going to present two solutions. So the first one is called ABQM 4.0 Changeover 6 Flexo. It's actually a prefabricated and pressure tested solution, which is used in 4-pipe heating and cooling systems. And the main goal, the main idea when we were designing this product was to design or to offer to the customers compact, easy to install solution, right? That was the goal, where we can actually switch between heating and cooling with one radiant panel or one heat transfer unit. Okay, for so control wise or control performance wise, we are offering our superior solution called ABQM 4.0, which can together with Novocon can offer superior pressure independent or real pressure independent control performance, as well as together with digital actuator, it can offer digital and BMS integrated solution. At Mostra, today we are presenting our, I would say, next level offering, including energy features, since we installed two temperature sensors, one on the inlet of the unit, one on the outlet of the unit, and together with the flow, which we can detect from the position of the valve, we can measure the energy, or we can measure the energy usage of the unit. Our second solution we are presenting at Mostra Convegno exhibition here in Milano is actually ABQM 4.0 Flexo, which is a Danfoss commercial name for FCU kit or fan coil unit connection kit. It's a prefabricated and pressure tested unit, and actually it's offering 8-in-1. So what more or less is hydronically needed, we are offering here with these solutions. We are offering real pressure independent control performance, we are offering balancing function, we are offering flow measurements, troubleshooting, we can offer isolation of the unit, we can offer flushing, backward flushing, etc., etc. Also here, ABQM 4.0 is taking care for the pressure independent control performance, right? But what I would like to especially highlight is our new modulating actuator called AME 110 NL. It's a new product. It's coming in the summer, and it will bring a lot of new features, like improved IP protection rate, right? Like it's more compact, and it's also improved control it can offer. Okay? So on this boot, these two, I would say, solutions are connected via controller Alsmart to, I would say, a simple demo panel where we can change a couple of parameters like flow, like temperature. And since we are using the cut samples of the valves, we can change the parameters and we can see how valves are actually moving. So the general idea was to make the conversation or the, let's say, discussion with the customers more interactive. So I'm looking forward to many good customers and good discussions.
I have also one question for you, the last one.
Yes.
How these solutions contribute to increasing energy efficiency?
Very good question, very relevant question, since we are all focusing on energy efficiency, right? So the main element contributing to the energy efficiency is actually pressure-dependent control valve. This is the technology invented by Danfoss back in 2004, and with 4.0 we really improved control performance. So in general, what is important is that each unit is getting just the right amount of flow at different pressure, full load, partial load. So all what we can achieve in way of energy efficiency is done with ABQM.
Super. Thanks a lot. Thank you, guys. So we have been discussing about the relevance of heating and cooling in commercial buildings and how our solutions contribute to energy efficiency and decarbonization. Let's now move with our colleague, Ivan Rangelov, to discuss a bit about our solutions for industrial heat pumps. Hello again, guys. You can see we are here under the industrial heat pump wall with our colleague Ivan Rangelov. Ivan, you are Industrial Heat Pump Business Development Manager, right?
Yeah, that's right.
Super. Can you tell us a little bit more about your background at Danfoss?
My background is thermal engineering. I've been with Danfoss slightly over 6 years, and in total I have more than 10 years of experience in the thermal engineering field, focusing on refrigeration, coming from industrial refrigeration, meaning generally ammonia, CO2 for larger capacities. We saw also big growth. Lately we see a lot of hydrocarbons, propane among others. In the last couple of years I focus a lot in industrial heat pump applications. A lot has been happening in the market over the last years, and now it really is growing fast in the new products and technology developments and new opportunities. Very much more diverse than purely refrigeration.
Super. I have some questions for you. Which heat pump technology is the best for industrial applications?
Well, that is a very complex question. It doesn't have a simple answer. One needs to map properly the application needs for process heat, such as capacity, temperatures. Then if cooling is also required, you need to do the same, temperatures, capacities, concurrence of processes. Do you need cooling at the same time? Do you need heating? Or when do you need one? When do you need the other? Then you need to map all available heat sources. And if it is a new project, then you are much more flexible to implement the best technology that you find. But if it's a refurbishment project, meaning you need to build something on top of your existing refrigeration site, then it is a little bit more challenging. So once you do properly your homework and you map the application, then quite a few technologies will be filtered out. And then with the left, ideally, you should make a total cost of ownership. However, this is also very complex, and often people look into just part of the total cost of ownership equation, such as efficiency, COP. Everyone is talking about COP. Yes, that is important, very important, and it's the first factor that we look into, but it's not the only one. Then investment, cost, now. This is another factor, serviceability, experience, what is future-proof. Is it the technology that we use now is going to be allowed in 10 years, or is it going to be future-proof? That is another question. And also, not the less, what is our experience? And once we have mapped all of this properly, then we can evaluate all the technologies that we have available and make a proper selection. So, quickly, to answer your question, there is not one diamond solution which is always the best. You need to consider all opportunities and find the best fit for the application.
So, this is a little bit related with my next question, okay? What are the best applications for integration of industrial heat pumps?
That is another good question, David. If you ask me, I would always start with applications which require both process cooling and process heating, because it gives you firstly the best or the fastest return of investment, and secondly you have an obvious heat source, waste heat from the refrigeration plant. You can have different technologies and the different applications. Obviously, food and beverage, textile industry, chemical industry, pulp and paper, just to name a few, they both require heating and process cooling, right? Historically, people use refrigeration just for the cooling purposes, the refrigeration side, but the process needs they're solved by fossil fuel boiler, gas boiler. That is the standard for many decades, and this is exactly what we need to change. We need to be more sustainable, more environmentally friendly, and nevertheless it's also cheaper. It is less equipment to install. So we need to think of one whole entity, process, cooling and heating, rather than for each other separate.
Okay, so following that dynamic, my next question is, do we have or are there some innovations which Danfoss is introducing in the portfolio targeting industrial heat pumps?
Oh yes, definitely. There are many technologies we are developing our components to comply. Actually, a lot has already happened over the last few years. We have a lot of components available for the commercially approved technologies of heat pumps which deliver hot water up to 90-95 degrees. We have compressors, we have heat exchangers, we have valves, we have controllers, we have hydronics, so we have a lot which is already now used in heat pumps up to 90-95 degrees. This is not little and has happened, this development only over the last few years. Nevertheless, we have quite a lot going on, and we are here next to one of our newest launches. This is the biggest box compressor which is released now, well, next month. This is the new 6-cylinder size transcritical box compressor with sweat volume up to 60 cubic meters. We target in a couple of years to go also higher in the sweat volume, maybe up to 100 cubic meters. This is a clear trend in the CO2 market. As I said, CO2 is going bigger and our components are also going bigger. Compressor is one example. Another good example is the industrial valves for transcritical CO2 applications on the other side of the wall, which we started launch already last year. It can be seen in Cool Selector. There is also more to come by the end of the year. And also with our new iCat B, it's a completely new generation actuator of our ICM. We are very proud of it. Next year also is coming our industrial size transcritical gas ejector, which we should also not underestimate its impact on efficiency improvement of transcritical CO2, which is for heat pumps, right? On the other side of the wall, there is also a heat exchanger, which is also transcritical CO2 targeting. Now we are still at the smaller sizes, up to 150 kilowatts. Next step is going to 300 and more kilowatts. This heat exchanger is also launched this year. And I should also mention that, yes, this is what we have about CO2, right? We also have a controller, which the new platform was launched in December last year. We also are working on several projects for development of application. But this is still below 100 degrees. What is really hot is actually above 100 degrees, where we target steam generation. This is the hottest thing on the market and the newest development, where we, for example, have for now up to 100 degrees. We have scope compressors over there. We show one scope compressor, but we develop a couple of those for both hydrocarbons and low GWP refrigerants. As the first step is condensing up to 100 degrees. We already have prototypes ready for release or for test on the field this year and launch by the end of the year, commercial launch. In a couple of years, we also target to go to 120 degrees condensing with these large scope compressors. I would say up to 140 cubic meters sweat volume. This is big for scope compressor. We're very happy about it. With bulk compressors, we are on the same track. We also target higher temperatures, higher capacities, also with both hydrocarbons and low GWP refrigerants. We are a bit more ahead with bulk compressors, as we have multiple field projects going already above 100 degrees condensing. 120 We have also test project in a lab going to 140 degrees. The challenge is that we also need to test not only the performance, but also the serviceability and the behavior of the components over a longer period. With Palladio, we also have partnership. They can be also seen in Cool Selector, and we're also going in the same direction with them, targeting also higher capacity. So we have a lot going on in compressors. It's not only the compressors though. We're going into the same direction with our heat exchangers, both brazed heat exchangers. We also have a lot of gasketed heat exchangers with our valves, control valves. And again, the trucks are hydrocarbons and low GWP refrigerant, and of course the good old ammonia. It's always there, and we have the right development to support it on our valve and solution side.
Great. It seems a lot of exciting news for the coming years. Anyway, my last question. What are the challenges of developing and integrating components for industrial heat pumps? What are the challenges you are facing?
There are two types of challenges. One is challenge to develop the component where you need to make sure that you have the right gaskets, the right seals which comply for 24/7 operation at the higher temperatures, which industrial refrigeration or refrigeration systems do not see. So it is component-related challenge, which are seals, gaskets, and lubrication. A lot is going on in lubrication, and this is also quite difficult to find new solutions for higher temperatures. Another challenge, which is probably even bigger, is in integration. As I mentioned at the beginning, our project integration is much easier if we have a new site where we start from scratch. We can be much more flexible. However, when you have existing site, existing system, then there are many more restraints, and it is much more challenging, the system integration. The technology, the components, they will get developed. That has happened a lot over the last years, and I believe that very soon is happening much more. But the integration is the big elephant that no one really is talking.
Okay. Well, thanks a lot. I appreciate the fact that you took the time to spend some time with us. But guys, stay tuned because, well, we have been showcasing a lot of our solutions. You can even go to our website, mce.danfoss.com, and you can be able to watch all the video recordings from the experts and also all the solutions that we are showcasing here at the booth. They are present at the website. So remember, mce.danfoss.com. Thank you. So that was it for today. Thanks a lot for tuning in. I hope you have enjoyed this live stream as much as we did here at the booth. Remember, everything, all the information is at mce.danfoss.com. Over there you will find all video recordings with the experts and all the solutions that we are showcasing here. Also, stay tuned on our channels, social channels and YouTube channel, because we'll be sharing more information there. Again, thanks a lot for